Usually every day I go into the garage and I look at the charge controller to see how it's doing. I usually have a single 100-watt light bulb running off of my inverter, as this is putting out 150 watts continuously with a 11 gallon per minute nozzle, but it's not at full voltage. So normally I would expect, I looked at it this morning, it was like 83, 84 volts, and normally it should be 160 volts DC going into the charge controller. So there's something goofy here, and I can tell kind of looking at the nozzle that it's not a steady stream. So clearly we've got some sort of debris in here. So let's take it apart and see what that is. So I can shut this off here. And then the cool thing about this is, well, I'll open this, which lets air in. Okay, sorry, we're back. I got a call. So that's draining out right now, supposedly. I would expect to see an air bubble. So I don't know what's going on there. Unless it is, I think it is empty. Okay. Well, the nice thing about these fittings that I got is I can very quickly and easily just disconnect. And then let's take a look at this nozzle here, see if there's anything in it. Let's go in here. Yep. Look at that. What's that? It's not liking that. Let's get a stick. Okay. What is that? This is... looks like a piece of PVC pipe that got stuck in the nozzle. Okay, well, let's put it back together. Also, I tried this bigger nozzle here, and previously it had worked fine, and there's the tip of it you see. But that was with the smaller hose, so I think I was getting a lot of pressure reduction on that hose. But when I hooked it up with this big hose, it blew that right off because it was seeing more pressure. Alright, now we can put this back down. I'm trying to do this one-handed, it's a little bit more difficult. Put that on there. Okay, well, this is a two-handed job. I'll be right back. Okay, I got it put back together. Now we can turn it back on. Shut this off first. That's filling with water. Okay, let's open it up the rest of the way. So we got a nice watertight connection there. Now we can turn this back on. And with that single nozzle, we're at 175 volts approximately, which is really high. This is a 200 volt charge controller. So we're near the maximum. I don't even have all the jets on. It's just one jet. So let's turn this on. Mode on. Status. And now it'll try to pull in volts, and it'll go to 170, as we'll see here. And like I said, here we are at 170 watts. Okay, I have dumped the pen stock. I opened up one of my tees here, so it's free flowing. And I already took a measurement of how long it takes to fill up this 5-gallon bucket, but we'll do it again for you guys to watch, and then I'll go over a little bit about what I'm planning on doing today. You know, that crystal clear water. Except for whatever's in the bucket as debris. Okay. I measured it. Took 13.5 seconds right before I started recording this video. And that equates to 22 gallons per minute that are flowing out of the spring right now. And I got the stuff to hook up the second hose here, so I'm going to do that. And I wanted to know how many nozzles or what size nozzles I could put on there. So I have one that flows around 11 gallons per minute, and then I'm going to put another one on. I think this one is the only other suitable one that I have that fits. And this one will do like 8 or 9 gallons per minute when it's full open. So that's my plan right now. And I have another nozzle coming, and I don't have my lathe working yet, so I can't really machine appropriately sized nozzles. So that's future content. Okay, push that back down. That threaded fitting might move. We'll see. Okay, let's see if it works. Gonna make sure this is off. Those guys are off. Electrical is out of the water, and everything here is tight. I didn't loosen anything else. I just tightened up that one and that one. Okay, let's give it some pressure. Okay, she's holding pressure. That's good. You do see a little bit of a leak around that threaded fitting, as I expected. There's no flats on that to really tighten it up, so I need to get a strap clamp and do that. Actually, let me go do that now. Okay, I have my strap clamp. Let's see what we can do. I'll turn this off, and then I'll open this up. Let the pressure out. Loosen that up, and then I should be able to put the strap clamp on. Let's see. It would want to go this way. Okay. Nothing. All right, let's take this the rest of the way off then. And try again. Hey, it moved some. That's good. Nothing. Of course, I can get tighter by hand. All right, that's. I don't know that we're gonna get any tighter than that. Okay. Let's try that again. Okay. I tightened that up some. It doesn't appear to be leaking so freely now. We're at full pressure. I'm not too pleased with how the hoses intersect there. Like, it doesn't look clean. Anybody who likes cable organization would know what I'm talking about. So I think I need to get, they sell barb fittings that are at 90, so the hose would be shot straight out that way. And once I get a turgo housing, the hoses will enter from the top instead of the side, so I should have more room underneath that to get hoses underneath too. Okay, well, let's turn it on. Here's the one that I just hooked up. And that was a good representation of how fast the water is flowing in there, and that is not very fast. All right, let's turn on the other one. All right, let's go inside and see what that's doing. All right, that's up to 230 watts, but it's in float MPPT. I had my computer running on the batteries for the past hour while I was doing those upgrades, and so now it's just filling those batteries up a little bit. Let's add some loads to that. Okay, I've added 2 additional light bulbs on the inverter. Let's turn my computer monitor on. Yep, there we are. Let's see what that does for our power consumption, because now it can pump more power into the battery. Let's see, it's still not increasing. Okay, let's add some power then. I have this inverter we can turn on. And then I need some more loads on it. Heat gun, anyone? I know it'll run it on low, so let's put on low. It's not liking that. Alright, let's do something else. Okay, it's still not going into bulk, I'm not sure why. But we're putting out 300 watts, and it'll be able to do this for many days at a time because we're not consuming as much water as available. Battery voltage is increasing, amps at 25 amps output at 12 volts through these 4-gauge wires. This is a set of 10-gauge wires that runs to this sine inverter, and then the 4-gauge wires that runs to this 1500 watt inverter, which can't even seem to run a 750 watt heat guns, so I don't know what they're on about with that. There you can see, oops. Yeah, 1500, and it won't even run a 750 watt heat gun. Maybe that my wires are not big enough or the battery's not sufficient to drive it. It could be something like that. It was complaining about low voltage. Maybe the voltage tuning on this is off because it's reading 11.7, but my battery's at 11.9 according to that. Now I can't imagine there's 0.2 volts of drop over these 4-gauge wires. So I have multiple incandescents, a few CFLs on there, and then also I still have to fix that motor for the lathe, and then multiple incandescents, and then my computer here. Also, I don't know if you guys know, but there's like a eBay partner program, which I'm kind of a member of, and we can see that there's a ton of clicks, but unfortunately I haven't been granted access to the partner program, so I'm not actually making money on those clicks yet, and I could be. Okay. Yeah, there we go. Well, that's it for this video, and I will see you guys around. Bye. Okay, well, there's bubbles, which means that my actual flow is more than 22 gallons per minute, and we're down below operating pressure there. So I need to switch out one of the jets to a smaller one. I have this smaller one here that I 3D printed, so I'm going to put that on, and that should resolve any issues. Also, when I did that video on a trompe pump, oops, sorry GoPro. When I did that video on the trompe pump, those bubbles that you just saw, that's exactly what I was trying to imitate, but I didn't have enough flow to imitate that. So those bubbles that were in there were at 100 psi, and if I siphon those off into a pressure tank, then I would have compressed air. Okay, back up to operating pressure. All the bubbles came out pretty quick, apparently. And we'll turn it back on. I'll do the small nozzle first, so we can see it. An observation that you might be interested in seeing. You see this bubble? It's there all along to here. Let's watch what happens to that when I turn the pressure on. And now it's from there to there. It's a lot smaller. That's what pressure does. It compresses the air into a smaller size. In this case, it's 7 or 8 times smaller than unpressurized. And here's that big gauge I was talking about. The unfortunate thing is the difference between this was showing like 122 psi. It seemed to keep increasing. Well, this is bent up and it's falling around a lot, and it's not very accurate. And I imagine this one is a lot more accurate. And we can see that the maximum pressure there is 110, 20, 40, 60 and a half. So 117 psi static pressure. And then I got another one of those nozzles and I put it on. And of course I don't have enough water to run it, but it works. Oops. I gotta turn it back on again. You guys love hearing this, so why not? Yeah. And you can see the pressure wave as it goes back and forth through the line when I turn these off or open it up. You could also see that as they were operating, the dynamic pressure, that was the operating pressure, decreased because of friction in the pipe eating up pressure loss or creating pressure loss. So I like that that's big and it's easy to see on camera compared to that. I mean, obviously, one's easier to see. So, thanks eBay. It's only like 20 bucks, 25 bucks. Okay, back on.